Welcome back to our second session on Hugging Face Transformers. So today we'll be able to see, different kind of libraries in Hugging Face so that we'll be able to use them to train a model. Based on our discussion yesterday, we saw that the capability of these, giant transformers. We also saw that, the transformer, Hugging Face transformer, it contained a lot of things like the model, data set, like you load your data set that you want to train your model, the metrics, where you can be able to use the metric to measure the performance of your task, and, the accelerate, which is a library that allows you to, run models on multiple GPUs. And, there is also a new library in Hugging Face Transformer, which is called, Evaluate. So now there is a new library called Evaluate that allows you to evaluate your models, just like metrics in scikit-learn. Now, recently, there is a data set called, library called diffusers. This diffusion models allows you, to model text to image. So these are a lot of things that now available in Hugging Face. But today, what we will see is we'll start seeing some of them, like library, recognizers, and then we can go and train a model, fine-tune a model, and see how we can do that. Okay, any question regarding to our previous discussion yesterday before we move on to today? Any question? Don't forget also, like, everything we were doing is from this book, Hugging Face Transformers book, Hugging Face NLP book. Yep. So don't forget, this is the, today we'll be seeing this chapter 2 of this book, because we are working, it's more or less good to work to do the introduction through this material. And don't forget, you can run them through Colab, Kaggle, Gradient, or, this if you want to see. So if you want to see what we are doing today, you can just click here or here, and, you can follow along. Let me share the link to people that just joined. Okay, right. So let's move on to, chapter 2. Okay, so the chapter 2, basically what it discusses is about, data set, tokenizers, transformers, and yeah. So if you want to train a model, the first thing we know we can do is to load the data set to identify which data set, right? The second thing we need to do is, tokenizers. Now, if you have your data set and, you want to train a model on that data, the next thing is, you need to convert that data set from raw text into, tokens of digit, because our models cannot understand any text. You need to convert those texts to, some tokens of numbers. That's the function of tokenizers. Transformer, this is a library that allows you to train model, because now you have your data set. You say, okay, I have my data set. I now convert this data set into token sequence of numbers. The next thing is to train a model with those sequence of numbers. That is where transformers come into. So then finally, this data set, we can see we have something data set. What is happening here, you can see we load the data set here, but here at the end, we also have data set, because this library called data set has, capability to evaluate the model. It has metrics in it. So, but if we, because now this is something that, the book was written like last year, but now instead of, if they will write the book now again, instead to have data set now, what will happen here is a library called Evaluate. So let's quickly look at these libraries in Hugging Face. For example, we can see Evaluate, Hugging Face. So you can see this is a library, Evaluate. a library for easily evaluating machine learning models and data sets. So you can see like, a lot of stuff about the library evaluate. Now, you can see the data set. So this is a data set. Okay, let me see this. Let's go here. Okay, Hugging Face data set. So this is the library data sets that we'll be using to, load your data. And, this is a library with help and everything, the tutorial about the data set, how to load the data set, how to load audio data set, vision data set, text data, tabular, because we have different kind of data set. So this data set take care of that. Then we have tokenizer, as I mentioned, tokenizer. And this library, we can see, this is tokenizer. So you can see a tokenizer, it's in charge of preparing the input for a model. You can see this is it. It's in charge of preparing the input. This is our input. So it will prepare the input to the model. That is the task of this library tokenizer. We can see there are a lot of stuff, to do that. So this is about tokenizer. And the last one, transformers. So we can see here, this is the last one, transformers. So this is a library state-of-the-art machine learning or deep learning model in PyTorch, TensorFlow, and is it called JAX or YAX or IJAX? So this is also another framework for deep learning, as we all know, like PyTorch, TensorFlow, JAX or whatsoever. What is it called? Anybody can help us? Is it JAX or YAX or whatsoever? Okay, it's just right, because like I'm confused. Some people, you see them saying yaks or whatsoever. So anyway, so because the reason why the transformers are in different kind of framework is that some people prefer to use TensorFlow, some people prefer to use PyTorch, some people prefer to use this language. So these transformers, they are now implemented in all of this framework. So you can use them in any of them. So that's about transformers. Yep. So you can see here transformers. The library. You can see we have many kind of transformers. You can see that we have Albert, BART. You can see the BART tweet. You can see a lot of transformers. I mean, language model that you can just use off the shelf. You can see them. You can see there is a table, the model, the tokenizer, fast, whether there is support in PyTorch, where there is support in, TensorFlow, where there is Flask support. You can see that. So this is the library, tokenizer. And today, what we'll be able to see is just to see, to see one of them. So let me quickly show, for example, here, this is you can just go and sign up for Hugging Face, because if you want to do practice, you need to sign up. Just go to the website and sign up. It's free. You can see, like, if I want to see the data set available, I can see this data set. Now, if I want to search for data sets for test classification or sentiment analysis, I will come for test classification, because there are many tags. You can see the tags, text classification, text and a question answering, token classification, many different kind of tags you can do. So what you need to do is to find the data set for your own tags, is just to click on test classification. And, you can see many data set for test classification. When I click test classification, okay, test classification, you'll be able also to see the test classification you want to do, what kind of test classification you want to do. So this is, I can filter maybe sentiment. I can see sentiment. You can see, I can see sentiment data set, something like multilingual, different kind of data set. Yeah, so that's about this kind of different. Any question before we continue? Okay, so let's move on. So let's start looking at the first one, data set. Now, what we'll be doing now, we will work on a data set to do, train a model for sentiment, for emotion classification. The data sets, contains 6 classes: anger, disgust, fear, joy, sadness, and surprise. So the data set has, 6 classes. Now, the aim we want to do is to fine tune a language model. We're gonna select any language model from Transformers library and now fine tune it to, train a model to do classification with a discrete sphere. And, this will help us for us that we are participating in SumAble to start to know, how to fine tune a model. Because when we do this for, classification of 6 classes, then it is also the same you can do for classification of when you are discussing to understand like how to do for 2 classes. The only difference is, when you train your model in your training data, you have 2 classes for sentiment, 3 classes for positive, negative, but in here you have 6 classes. So we'll be able to see, how this data set is and how we can train the model. But before that, let us take a little tour on Hugging Face data sets to understand it better, so that we will be able to, deal with it. Now, if you want to know, how many data sets are available in Hugging Face. So Hugging Face is hosting a lot of data sets. So now here, when we import here from dataset import list dataset, and now a call for this function called list dataset, right? Now I print here list dataset, the length of the dataset, and here you can see I print the first, 10. So here you can see there are 14,300 dataset now available in the GitHub and the Hugging Face hub. So it's readily available for you. You can upload your dataset there. When you are training your model, you don't need to, download them, have your data set in your computer. You can just call your data set from that Hugging Face hub. So we can see like we have, this model data set, and, this one print the first 10 data set. So you can see here we have, because they are arranged from alphabetically, we have a data set called this. We have a data set called Africans, now Kofos, AG News, this, you can see these are, data set that are available at Hugging Face. So this tells us, we have many data. So now when you see, this is just for you to see the data set available. But now if I want to, see a data set, maybe called sentiment data set, and I don't want to load the sentiment data set to work on it directly. What I want to do is just to observe, the data set to see what are, some information about that data set. For you to do that, we can use what is called load dataset builder. This function load dataset builder does not download your dataset to your computer, because you just want to observe some dataset to just see different kind of dataset. You don't want to download it at this moment. You just want to see some information. So we can use this function, this class, load dataset. You can see load a builder for a dataset builder can be to inspect. You can see just inspection to inspect general information that is required to build a dataset. So we can see here a dataset builder. I say emotion. Give me a dataset information about the dataset called emotion. So I load it here, and now you can see I have dataset builder. So I can call some dataset.info. I can see a lot of information about that dataset. I can see like how many features that this dataset has. I can use this feature. So you can see like it's telling me it has text, and now the level. The number of classes 6, which are these, and you can see the data type, the text is of type string. So this is something future. And now you can also ask, what is the dollar? So what is the size of the data set? So this is the size of the data set still. From info, still you can ask this data set before this is all inspection before you start working on the data set. Now, how many splits this data set has? So you can see this data set has 3 splits: train, validation, and test. And you can see the, number of example in train set 16,000. You can see the number of validation 21. You can see number of example 2,000. I mean, you can see the number of text, which is also 2,000. So this is a data set of 28,000 emotion classes. And so somebody can now, in fact, this is the data set name, emotion. You can see that. So here you are just exploring a data set. You have not yet downloaded it in your computer. And now you can look at description. So you can see dataset info build info description. This tells you the description of the dataset, what this dataset is. So this is emotion datasets of English Twitter message with 6 basic emotion classes: anger, fear, joy, love, sadness, and surprise. So this is just trying to look up all the information. If you look at this, when I call this info, all this information are here. Description, because that is why I'm using dot. to access any, argument here. You can see that. So you can see we have description. You can even access the, citation. You can see, many other information that you may be interested. So that's, inspection of your data set before you download it. Now, if you decided, you are happy with the data set that, hey, this data set, I'm going to use it. So what you need to do is just use another function called load data set, right? So this function will load the data set from Hugging Face. So here we load the data set. You can see now I just call the data set here. You can see this. So here, the data set in Hugging Face in some kind of type, which is called data set dict, which is somehow looks like a dictionary, right? You can see you can train, we have validation, we have test. This is somehow looking like a dictionary. Can you see dictionary? This is a dictionary as well, so this data set is called data set dict, and basically, allows you to see that. So now this is our data set. Now somebody say, okay, I have train test. Now you can also at the same time, because this data set, it inherits a lot of normal Python stuff. In pandas and NumPy we do. So, in Python, you can just call a key to show you, the keys of your dictionary, right? So this one also show you the key of the data sets. Okay, we have train, but maybe you want to find out how many rows, how many train data set you have. So you can see, we can say data set train num rows. So this one gives you the number of rows of your data set. More or less, where we saw here some of the information here before we download using this one, where we said, the split. So this split tells you, the number of everything. But here you download the data and you want to inspect. And this one, validation num rows, and tell you the number of validation. Num rows for text tell you the number of text set, right? And you can also see, number of columns with that. So this is tell you the number of columns. But you can also see use train.futures for the training data set. What are the futures? Of course, we have text and level. Yeah, so that's basically about, exploring, downloading your data set. Now we understand how we can download a data set from Hugging Face. Now let's look at it, for example. Maybe, for example, I want to download a data set. Okay, let's go here, data set. And I want to download a data set for test classification. And the data set is, which kind of data is sentiment. So I have many kind of data set in sentiment. I can see here that their names contain sentiment, right? So what I need to do is, if I want to take this data set, one of them, what I need to do is very simple. What do I need to do? So you can see here that the data set is, it has something like the flamboyant news, this one. Can you see something like that? Flamboyant news sentiment data set. Okay, let me talk about, give an example, the one with emotion. Yes, emotion. You can see this is emotion data. So you can see the name of this data set is emotion, right? Emotion. You can see that. You can be able to see some example in Hugging Face. From Hugging Face, for example, you look at the test, it's at the level, you can be able to see some information about the data set. You can go to the GitHub page of this data set by clicking here. You can see a lot of other information and related data set models that are trained or fine-tuned on this data. You can see them, some of the models that have been fine-tuned or trained on this data. And you can see a lot of information about this data. For example, there is model data set card, there is files and version, there is community. So what is the meaning of data set card? So data set card allows you to give see a lot of information about the data set. So we can see here, this is the data set preview, right? And this is, data set card, which when we say data set card, we mean information. This is a summary of the data set. This is the language is supported. This is some information about the data set. And, these are a lot of other information. This is called data set card of that. Now, because here the name is emotion, that is why you can see when we try to load this data set, what we did is only this, look at it, load data set emotion. You can see that's how we load the data set, right? But what about if I want to load another data set, not like this, something like this, no, let me go back. Okay, what if I want to load the data set like this? You can see Rahumallah auto train detection, this data set. So what you need to do is to copy all this one, all here. You can see all here. Then you are copying the data set. And let me go another one. Oh, my data set is yeah. So because I'm I have another data set called recently, which I uploaded. So you can see if I want to load this data set, what I need to do is my account. I copy this one here, and now I come and paste it here. Yeah, something like this. So that's how I will be able to load the data set. So yeah, yeah. So that's about Hugging Face, how you can load the data set and how we'll be able to use it. Now, any question before we continue? Any question? Okay, so going further, splitting the data set, when we load the data set, you can do a lot of things. Number one is you can split the data set, right? What I mean by splitting the data set is, you can, say, okay, you are not here. We can see we just load the data set, the whole data set, emotion. We don't specify whether we want to load only trained data or train or test or split, but you can load only training set from the data set. So here you can see we load only, training data set. You can see I load only training data set. I need to specify this split train data set. So here I have my training data set. So you can see I have my train data set. Yeah, so you can do a lot of other stuff with your data sets, such as indexing. We know just like Python, you can index the data set here to give the first data set. And you can, do data set column to give you you can do data set 1 to give the second data set, but you can also index, here means first data set and give me the first column, because I have 2 columns, text and level, right? So this will give you the data set. I don't feel, I don't feel humiliated. Yeah, so this is a lot about indexing of the data set. You can see another thing is, right, so in pandas or in Python, we know when we load data set, we know our data set in some kind of format, whether the data set is in, pandas, whether the data set is in, NumPy, but data set in Hugging Face data set is not pandas data set, it's not NumPy data set. Look at it, it's type data set arrow. So it is of one type of data, one type of, data format called arrow. Anybody knows arrow here? Anyone knows, arrow? Okay, so let's look at what is arrow. So as you all know, pandas, NumPy, you can use to represent data set. But the problem is in machine learning, the data set are so huge. Sometimes you can see a data set of 16 gig, 13 gig, 14 gig. Now working with this huge data using pandas or NumPy is not efficient. The best efficient way to deal with large data is a data, is what we call, arrow format. So arrow is, is a different kind of, way to deal with data, and it has a lot of advantage. Speed is very, it has a feature called support zero copy read, which means that it can read data directly from memory without copying it. So this is data that is, arrow allow model to read the data directly from, memory without copying it. So, because in computer, we need to copy something to memory and stuff like that, and that takes a lot of time. So arrow allows to do. There is a lot of compatibility interpretation. So in a nutshell, data set in arrow is efficient, and now Hugging Face, that is why Hugging Face is using it. And we can see here, we can basically use, download the arrow format using a function called dset data.table by using another package called Polar, which also just like another data frame, another format of data frame, which is so fast, built on Rust. So we can, download. So this is just telling you, this is not part of it. I just added it. It's just telling you like what is going behind the scene about the data type of data set. We know pandas or NumPy, but Hugging Face data set is what we call arrow. Right. So you can also do slicing. Remember in Python, we can slice our data frame. This give us the first 3 data example. You can see this is I didn't feel humiliated. the second one, the third one, and these are the levels. So this is, you know, insect and slicing, we already know. This one gave me from 3 to 6. So that is about, you know, one of the functionality of the data set. Any question before we continue?
Yeah, Assalamu alaikum. Doctor, good morning.
Morning, Rajiv.
Thank you for this presentation. And my question is that, can we use this arrow for small amount of data sets?
Yes.
So that it can...
Yes, everything. Yes, you can use it. Yeah. So if you know, you can just Google arrow and you can see more information about arrow. Yeah. So yeah, another thing with data set you can do is it's not only loading the data, you just load it, but allow you to do some pre-process. You know, remember when we have a data set, before we work on it, we need to pre-process, right? So the library data set allows you to do some kind of pre-processing on your data set. So the first thing you can use tokenize. You can tokenize the data and
Yes, we can see your screen.
Okay. Any question before we continue? Okay, now since we have seen now, you know, a lot of things we have seen now with we can work with the data set. Now we understand that Hugging Face data, this is where we stop. We understand that the Hugging Face data set is not in pandas, it's not in NumPy, but in Arrow data set. And we talk about what is Arrow because of the speed and other stuff. And now you will be able to see the underlying Arrow data set by using, you know, data set, the table. And now you can see I load the data here and, you know, using the function called another data frame format called Polar, we will be able to see, you know, the data in this format. We have just seen how to slide the data, just like normal Python slicing. So Hugging Face inherit all of these features from, you know, pandas. You can work with that. But the next thing is, you know, you need to pre-process your data. The Hugging Face data set allow you to do one of the cool things to do that. So we can do what is called tokenization. So Hugging Face has a library called auto tokenizer. The function of auto tokenizer, we already know what we mean by tokenization. If I said I love, you know, if I said I love this car, right? Tokenization, you know, allow us to divide this, you know, into separate token, you know. But we remember that the tokenization we need to train a model is to convert all these tokens into numeric format. So auto tokenizer from Hugging Face allow us to do that. So here I import from transformers, import auto tokenizers, and now I want to load a data set here. So auto tokenizer, we have something here from pre-train. Remember yesterday we talked about something pre-train. That is a language model that is trained already by other people. So since it is pre-trained, you just load it. And when you load it, you're gonna use only the, you know, the weight of that model so that you can fine tune it to your task. Remember, we talked about this yesterday about fine tuning and pre-train. So here you can load pre-trained model. So using pre-trained model, these models, they already have a tokenizer. So for example, BART has a tokenizer. All of these pre-trained model that have been trained, they have been trained with their tokenizer. So here I'm loading, you know, the tokenizer that have been used for BART model. So here you can see auto tokenizer from pre-train, which pre-train? BART auto tokenizer. And now here is the data set that I load that I want to, you know, tokenize it. And you can see the data set here I load as an example, rotten image, rotten tomatoes. I already show you how to download the data set, but I'm downloading only the trained data set, not you know, all the data set. I'm downloading all it. So now you can see here we have load the, you know, BART tokenizer, and now the thing that remains for us is just to do the tokenization. So you can see here data set, because I have data set here, data set 0. The first one I'm loading the, you know, the first data set, the first text, right? The first data set in the row and only the column text. We can see this is the data set. So we want to, you know, tokenize this text to give us a sequence of numbers. What we can do is, you know, because we already have our tokenizer here, we can see that, then we can apply this tokenizer on this data, on this text. Because this is our text, we can see it here, then we can wrap it into our tokenizer, right? So here we can see we tokenize. So we can see here, yeah, so we can see here we have our, you know, tokenizer. When we tokenize, we have this D. We can see this D is now represented as 101. No, 1996. we can see rock is now represented at 2 6. This 101 is representation of something called CLS. We'll discuss about this because tokenizer, when you tokenize, the beginning and end of text is represented by something. So this is something that, yeah. So for example, 101 means the beginning, 102 means the end of your text, right? So this is something, because this one here, you can see the rock. Let me show you the rock, because here you can see I have the rock. I have, it's going to make fly and what's okay. Let me run this again and see. Yeah. Oh yeah, let me run this again. Yeah. I downloaded, I was looking at something different. So you can see, because here I said, the first, text, I feel humiliated. I didn't feel humiliated. I have the first one. You can see the first, here it means this is the beginning. Then this I is represented at this, but the end, we have something here, 102, meaning, no, here, this one, 102. Yeah, I think I'm right? Oh, here I'm also slicing the first two. Let me just show. Yeah, so you can see here the first, because I have only one sentence, I didn't feel humiliated. The first thing here is 101, the last one is 102. What is happening is when tokenizers, they put some thing called, token at the beginning of the end to show the beginning of a sentence and the end of the sentence. So if, for example, here I said who data set, yeah, we can see here the, let me show us here also. Right, you can see we have two, right? The first one and the second one. So you can see the first one here is this, right? The second one is this. You can see 101 at the beginning, and also we have 102 at the end. We'll discuss about this later when we come to discuss the detail about, architectures of this. But just now, when we do tokenization, what you need to understand is that when you tokenize, I said, it gives you, a lot of information. But let's see those kind of information again. Let me go back to make it so simpler to explain. Yeah, so you can see here, we tokenize this text. It gives us into sequence of numbers, but this sequence of number, it gives us something called input ID, which is this, and it gives us what is called token type ID. It gives us what is called attention mask as well. But don't bother about this. We will understand, we will, learn them a lot, but you should know that when you tokenize a text in using pre-trained model, the output is two things. Input ID is just the IDs of your text, but it comes with something called token type ID. It comes with something called attention mask, which we'll discuss them in later. But just a bit the introduction, the input ID, the number representing the token text, that is the number representing each text. The token type ID indicates which sequence a token belongs to, because we have different kind of sequence, 1, 2, 3. So if a sequence, because we can see the sequence here, we have the first sequence, here we have 0, 0. So if we have another sequence, we can have 1, 2, 2, something like that. Another one, we have attention marks, which tells us that indicate whether the, a token should be marked or not, which we'll discuss in, Transformer if we come to the architecture to explain it in some days. But just know that. So what do we mean by masking? So in pre-trained model, okay, let me show you this again. Here that we use architecture called BAD, base case. So what is the meaning of this base case or something like that? Can you see my browser? Yep.
No.
You cannot see my browser?
Yes.
What about now?
Browser.
What about now?
Yes.
Okay, so let's look at what does that mean by that, let me put bad base. Yes. So what this means is like, these language models, they are trained, and sometimes they are called on case, sometimes they are called case. What is the meaning of this? This is the model we call, you can see the bad base case. The meaning is that some model, okay, yeah, you look at them, they are of different type. Meaning the case means is of, what do you call it? How say, in case, what does that mean? But I made a small later, case, how do you say it in case? Remember, remind me. Anyway, you just understand what I mean. So, okay, yeah. Yeah, well, Mariambaki, exactly, Mariambaki, something like that. So this model, they are being trained of different types. Some are on case, smaller, lower case letters. Some are called base. What do we mean by base? They are small. You can see 110 million parameters. But large on case, 340 million. That is large. But based on case one, you can see them. We have case whatsoever. Then we have multilingual. What we mean by multilingual is that this model is trained on multiple languages. Hausa, Yoruba, more than like 300. I can't remember exactly the number of languages, but you can see even the language model, they are of different type. The same part is whether it's case or on case, whether base or large, whether also at the same time multilingual or on whole word masking or whatsoever. So there are different types. So when you load for the tokenizer, you should know what you are loading. So here we can see here I'm loading bad base case. If you are training for Hausa, this means that if I use this one also, it means that I'm not using the multilingual BAT. I'm using only the language, the model here that understand English, because this BAT base is only English. So if you want to do something related to Hausa or other language, you don't need to use this one only. You need to use this, BAT-based multilingual. So you can see that BAT-based multilingual. So it can understand a lot of other stuff. You can see a lot of information, and which data set this model was trained on is in Wikipedia data, and a lot of other stuff, like this. We can see something like this also. If we come here to visualize BAT, we can see, what I was saying, like, this is an example, the girl ran into the local. If we said, you can select the model you want to train, maybe I can say bad case, you can see the case is capital here. You can see it doesn't lowercase everything. If I say on case, you can see this is lowercase and other stuff. So this is something, to visualize some kind of what is line and stuff like that. Yeah. So let's go back to what we are talking about. So when we say the BAT, so language model are trained based on two types. Okay, basically to introduce some them, they are trained based on, most of them, they are based on what we call masked language modeling or causal language modeling. Yes.
Sorry.
Yes, go on.
So now, like in this case, how did you make the choice of using on case?
Yes, it depends on your course. Then you can say you can choose, so for example, if the task you are doing, maybe for example, I think if you are using machine translation, I think the uppercase letters matters, right? Idris, can you tell us, like in machine translation, if you use case and on case for machine translation language model, does it have effect?
Yeah, so I don't think it have any effect. Sometimes it's just experimentation. So if you have the compute, you have the time, you can experiment the two to see. It doesn't make any sense. Let's assume languages. Do languages change, or what does the meaning of sentence change just because you change the case or you don't change the case? Maybe, yeah, it's language dependent.
Yeah.
Maybe there are languages that if you change the case, maybe something will be different from something, but I don't think so here.
Yeah, I think, let's see.
Yeah, there's the second one, case versus on case basis. So maybe Kamarsu, if you are doing like name entity recognition.
Yes, exactly.
So
exactly.
Usually, if you have like, let's say, a capital, it might assume that here is a name entity.
Exactly.
My machine translation.
Yeah. So if you are using name entity recognition, names are recognized. For example, you can say Kano or Nigeria. So if you say Nigeria with capital letter at the beginning, it will recognize that it's, whether it is, yeah. So I think, in fact, just read, I don't know, I don't have it on top of my head, but you can Google. But of course, if these models are created by case and on case, they are having, their advantage, especially as in nano entity recognition. So yeah. Sami, does that answer your question?
Omar, because me, I was like thinking to, does that mean you have to kind of preview the content of the data set before you now decide whether to use case or on case?
No, no, no,
I
no,
thought
no.
it depends on the sentences. If they are in capital letter, then you use the case, and then if they are in small letters, you use it on the case. But it is clear now. Thank
Okay,
you.
okay.
I
Yeah.
think among Dr. Shamsu, when you are doing like let's say sentiment analysis, some of the pre-processing sometimes it even involves lowering the case. I go.
Exactly, exactly.
Yeah, because even like take for instance, you have machine translation. What you have to build first, you have to build the vocabulary. So if you have different cases, sometimes it might have two words inside your vocabulary, which ideally are the same thing. But when building the
Exactly.
vocabulary, since the cases are not the same,
Yes.
they are
I assume
represented.
they are different.
Yeah.
Yeah. So what you're saying, like now, if for example I have this, I I love this cat. You look at this guy is doing tokenizing for me. I didn't ask you. So what I'm saying here is that when we have, for example, another law, so if we want to tokenize this, tokenize this guy, tokenize above sentence. Let's see if it will. Yeah. So you can see here, like it trying to tokenize it under telling me like love is one word, but love with this big love is, separating it is single word, different kind of word. So, okay. Anyway, let's go back and continue. Okay, so what I want to say, like here, I introduced something called, mask. So what is happening when you train a model? There are two kind of model, was widely trained model. That is what we call masked language model. That is what we call causal language model. What is happening in masked language model? This is masked language model like BAT. What is happening is this. All these language models are trained in two types. One is masked language model. You give a text, but you mask the one word and ask the model to predict what is masked. So now here we give the model all the, and now this later we mask it, we put it, we want the model to predict, and now we put this base. So the model now here you predict berry. This is what we call masked language model. We mask a word. But the advantage here, what this masked language model here is that it has access to what is left and what is right. That is, it will understand, it will predict the masked word by considering the context of left and right. That is what we call masked language model. An example of model trained using masked language model, example are BAT, Robata, Distal Bata. All these are masked language based model. The other type of language model is called causal language model. Causal language model, what is like, it gives all word and give a mask. It has access only to right, not this left. It doesn't have access to here, what is here. It has access, it only predict here. It doesn't have access to to this. This is, you can see here, we said under causal language model, the idea is again to predict the mask token in a given sense, but unlike MLM, the model is allowed to just consider what that occur to its left for doing the same. So this is causal language model. This could be just left or just right. The idea is to make it unidirectional. So here we can see the masked language model is bidirectional. Then the causal language model is unidirectional. So model trained using causal language model include GPT-2, GPT-3, T5, even the recent model from Hugging Face, Bloom is causal language model. So this is basically what this what I show. Yeah, example here you can see. We max a word, we ask it the model, Porter, Harry, it predict. So this is BAT model. And this is what we mean by attention mask, to max a word or what. Attention mask indicate whether a token should be maxed or not. So this is it. But just now for you to understand, if you want to, tokenized sentence, what you need to do is just import a tokenizer. You don't need to know about this detail now, but just telling you the idea behind, maybe we'll discuss them later. So you import tokenizer, load the data set, and now you import from pre-trained model called bad on case. It has a tokenizer when it was trained. You can see load the tokenizer, and now this is our data set. Now for you to tokenize, you just put this tokenizes. So now we see how to tokenize a single sentence. Now, how can we tokenize our whole data set? This is where it comes into the data set functionality of Hugging Face. Is really helpful. So it comes with a function called map. So here we can see we create a function called tokenization, and now given anything one, return tokenizer the the text in it. So here we can see this function. We can apply this function. So here we have our data set, the whole of this data set that we load. This data set, where it is, this data set, the whole of it. Here we are applying this guy, and we say dataset dot map tokenization. So this function, we map it into our data set. So this means that the whole data set is now tokenized using a single function map, which comes from the data set, not the map in Python map function. So this is a map from the Hugging Face that allows you to do this stuff. So we can see this is a map, and so now you tokenize your data set. The next thing you remember, if you are training your model, is since your data set is now mapped, you remember this is what we said. Now you have your data set, you have tokenizer, right? You load the data, when you prepare your data, you tokenize, then you pass your tokenized text to your model that you want to train, whether it's Hugging, whether it's PyTorch model. So the next thing tokenized data set allow us to do is to convert a tokenized text into a format that is suitable for your language model. So here we can see we can use set format function to set the data set form compatible to PyTorch. So we can now we made it to we tokenize it. We can use set format. We can specify which format torch. That is, we want to use torch and other stuff. Now you have your data set now ready to go into modeling. That is about data set, and you can use data set again to evaluate your model. So as we saw here, like a data set after loading it contains metrics to evaluate your model, the data set. So when you finish everything, basically you can use your your data set to load what is called. Here we list metrics available in Hugging Face, import metrics, and now we create a list of metrics available in data. We have accuracy, blue score, blue whatsoever, just like metric in scikit-learn. And if you want to find a metric of something, you just need to import load metric, provide the name of the kind of the metric, and the tax name, and you can do this something like this. Metric that compute, you provide the model prediction, and you provide the load reference. This allow you to do that. And finally, you can share your model, your data set on Hugging Face. It provides two ways to share your data on Hugging Face using Hub UI and Hub CLI. So here, if we come here, we can see. Okay, yeah, I can see here. Okay, so we can go here and see Hugging Face data set, Hugging Face. Yeah, so if you want to share your data set, you can see this is the data set. You can see everything here, but you can create a new data set here. You can see you can create a new data set if you want to upload your data sets to Hugging Face. Create new data set. You can specify the name, your owner that you decide the name of the data set. So kada, whether it is public or private. You can see, look, this one looks like GitHub, right? So it's this Hugging Face, it integrates flawlessly with GitHub. I can say this is private, and now create the data set. Now, when I create the data set, I can create the data set card. So this data set card allow you to write information about the data set, and now you can even upload the data set. You can upload the data set, add files, just like our normal. You can drag and drop your data set here and drop them. And this is you can see I have a data set called DDD. So this is telling us like you can have a data set using CLI, but also you can have the data set using CLI command line. For example, here installation. load data set from share data set to Hugging Face. You can see you can use upload the data set using Hub UI. Look at this. You can also use download it from upload using command line CLI. So this is it, how to push it to there. So this is really simple stuff we're gonna do. Yeah. Okay. Our time has gone while going through. So let's back to our, now we have seen, I think we have seen a lot of function of data sets. Let's quickly go back to our data set that we want to train. I believe now we understand a lot of stuff related to the data set library. Let's go back to our data set that we are trying to work on, which is emotion data set. I know time has gone, but let's quickly finish this section. So here we already now understand, how to load the data set. Now here we load our data set, and now we look at the data set. We have different kind of train, validation, and this. And now we, load the train data set here. And now here we can, see, observe the train data set only using this. We can observe the validation data set here as well. We can observe the test data set here as well, as we discussed. And you can find the length of the data set here using normal like pandas. And we can observe the data set using, we can see the first one, you can see the last one here as well. And we can print some sample of the data set. Yeah. So now we have seen the data set, but now what we mean is, we can change this data frame, data set. You can see that the data set is in arrow format. Now, for us to do some data analysis, remember in machine learning, we use pandas, right? So you can convert your data set from arrow format to pandas format. So we can say that, import pandas emotion set format, which type of format we want to change our data set. We want to change it to, if we look at this guy, we can see like, type, as we saw earlier, you can see the data set is in this format. Data set, data set date, different kind. So we want to change it. Let me show something. This one. Yeah, so, okay, one thing you should know is that like now here I try to load it. You can see that in a bit, it just download automatically. So when you load something in Hugging Face, it is cached, meaning like if you try to load it again, it will not be load from the Hugging Face, it will be load from your computer. It is now cached somewhere else. You can see already cache. You can see it cached from this directory somewhere else in here. So it is cached. So this allows you to just load something like this. So you can see the type. So we want to change this to, pandas. So we can set type using this function, set type. And now we can see our data set is in now, text and level. But we can see here, our level here is in, 0, 0, 3, 2, but the problem you remember here, as we already know, a data set, if you have this kind of ordering, your model will understand like, so here what this referring is 0 is one of the class, because we have 6 classes. We have sadness, anger, love, 6 classes. So each one will be given number 0, 1, 2, 3, 4, 5, 6. But you remember, if we want to train a model, this kind of ordering, the model will understand that is modeling inherent in it. So we need to change this ordering as well. So here we can use, instead for us to see these, levels as number, we can use this function called, integer to string, and to convert to, here we can see, we say the level, df level, apply, because we create this function, level to into string, and now collect all the levels. So here we can see the level in the data set. And remember, in machine learning, before you start training your data, you need to find, the classes, the distribution of your classes. So here allow us to see the distribution of our classes. So the Joy has, more classes. This means that our data set here is what is somehow, not distributed, in some, equally. So it is skewed. But remember, if you train a model with skewed data set, you may have, less, not good performance, because some classes that Joy may dominate the data. So it is, widely allowed to advise to use, to make your imbalanced data set to balance it before. So there is a library called imbalance LAN data set. This library allows you to balance your data set if you have unbalanced data. This is a good library that allows you to, explore. I think, Sami, one of your review for your paper advice, we make our data sets also balanced. So you can explore this library. It's very simple to make your data set balanced. One way to make your data set balanced is, randomly oversample the minority class. Meaning here, surprise, I randomly sample them so that it equivalent to this guy. I randomly this equivalent to this guy. That is randomly oversample. You can undersample as well. Majority class. This is a majority class. I can undersample them to bring them down maybe to this, and now sample here to be here. So there are many ways to make your data set balanced by undersampling or oversampling. That is also a good technique. But it is good also to know. Yes.
This oversampling, is it repetition or
yeah?
What do you mean by oversampling?
Yeah, so it's basically oversample. Yeah, it's basically repetition of your data set. So there are many techniques to do oversample, to do, to deal with imbalanced data. So for example, if I have a tweet, that says, I love this cat. Now you can basically create another sentence based on this, change the synonyms. Maybe love, what is the synonym of love? What is the synonym of love? I adore this cat. So you can see this text, you add one sentence in the data set, but it's still the same. It looks like one in the same data set. So there are many techniques in that. So oversample, in some ways it do oversampling some, sample in the data set, the same, but some allow you to do, data augmentation to make the data balance. So what I told you is one of the techniques for data augmentation, like to find the synonym, to change, to increase the number of the data to be that. Yeah, but yeah, something like that. But if you are interested, this is, imbalance. There are a lot of techniques to make data set imbalance, and it's really easy here from this documentation. If you go to make the data imbalance, to make it balance, it's just few lines of code. One can make data balance, and yeah. And also, it is good, because transformer, when we train language model, they are trained based on specific size of text, right? So we can see now what is the size of tweet in each, class, like anger, this, we can see like their sizes, up to this. We will discuss about that again. Right, that is, now we finish our data set, exploring the data set. Now we have seen how we can use language model to tokenize our data. We have seen how to load the data set. A lot of things about Hugging Face data set we have seen. The next one is allow us to, to see the next step from text to token, which we just discussed, tokenization. From text to token, allow you to tokenize the data set. There are many methods for the tokenization, character tokenization, there word tokenization, there is what is called sub-word tokenization. But basically the main idea for us to tokenize a text is just to use auto tokenizer. And now you can, your model checkpoint, which is, from pre-train that we talk about, this is just used to, tokenize your model. So we can see here what we did is now we use auto tokenizer. When we use auto tokenizer, it contains many models. And now you just need to specify which checkpoint you, I said distil bad, I provide a checkpoint here. But you can import a specific tokenizer for any model. So here I said from transformer import distil bad tokenizer. You can see here I download a specific, I'm importing a specific tokenizer for distil bad. So distil bad is another language model based on bad, but it is, distilled, meaning that it's not large as bad, but it still gives a good performance. So this is another language model I import is tokenizer. And now you can see from distil bad, from pre-train, checkpoint, that is, checkpoint like this. Or I can just put something like this here, just provide it here, something like this. This is, no. What am I doing? Yeah, just provide it like this is what you are doing from here. Yeah, something like that. So there are two ways here. When you use auto tokenizer, you download, everything, but you can use specific stuff. So that's how you tokenize your text, as we already saw. But there are a lot of theory about that, meaning about whether you want to use subword tokenization or whatsoever. But I think it's already time. We need to stop here maybe to continue from next week. So next week, hopefully, we'll be able to see we discuss continue discussion about tokenization, and we'll be able to see how to train the model. So we will be able to see how we can use this still bad model. This is the model. We can see how we can train the model. Discuss that, and we'll be able. So basically, there are two ways to train a model. We can train a model using using features. So there are two ways to train a model: by extracting the features from the model, and then by fine-tuning. So hopefully next week we'll be able to see these two ways, how you can train a model by extracting the feature and use the features in your traditional machine learning ways, or you can just fine-tune a model. But ultimately, fine-tuning a model gives better performance. Yes, any question? Oh.
Oh, Doctor. Question dina shine misali yanzu akwai model misali wanda yake da levels kamar guda 10 misali. So sai kuma nake so na fine tuning da data dina li kuma level din ba su wuce guda 2 ko 3 ba haka.
Yes.
So it is advisable na yi amfani da wannan model din ko kuma in samu wanda yake similar to levels dina.
Yeah. So what is happening is that for example, if you want to use BAT was not trained to do even classification. What BAT was trained is to use mass, to do mass language model, prediction of next word. So if you want to fine tune, for example, BAT, right? What you need to do is just to change the last layer that we talked about last week. When you want to do fine tuning, you just need to change this, remember here we talk about something like this. Yes, this head. All you need is your head is to fine tune with your task at hand, and your task at hand is level data, whether it is 2 class, 3 class, 5 class, you give the model with the level data. This last one, you fine tune it with a level data set, meaning you fine tune with the model, fine-tune the model with your data, so whether it is 3 class, 4 class, 5 class, 6 class, and the model will be able to understand those classes. So the main idea is just to get the language model you want to fine-tune, whether it is bad, whether it is still bad, whether Alberta, whatsoever. All these language models that were trained, they are not trained to even do classification or question answering in some sense. What they are trained based for pre-training, what they are trained for is just to understand how to make prediction of next word, whether mass language model or causal language model. That is what they are pre-trained to do. But it is when you use the fine-tuning that we discussed yesterday that will that takes you to specific tasks. I don't know if this answered the question, or you have something to add, or anyone wants to add something.
Assalamu alaikum, Doctor.
Yes.
Sanin da kokari. Yawa, question ina shine, please, is on this thing that we did yesterday. If now I have created my own model using deep learning algorithm, now I created my model. Can I use those transformer model to evaluate my own?
Yes. Okay, if I understand, you create your deep learning, you create your algorithm, and you want to.
Maybe I finished knowing my performance of my own, so I want to compare it with that of a transformer model, maybe the BAT, for instance.
Yes.
So can I do that?
If I understand the question, you want to compare performance. So what you need to do is, take your deep learning model, do the training whatsoever you want. When you finish, then take your data set and now train or fine-tune a language model, see the performance and do the comparison. I don't know if that's
yes.
Yes. So you take your data set and now use this pre-trained language model, fine-tune them, and for the tasks that you did for your deep learning algorithm whatsoever, and now come and see what is the performance between these two. Inshallah, next week, we'll be able now to see how to do this fine-tuning, on the Hugging Face on Saturday and Sunday, which will be really cool for us to start to see how we can train, how we can fine-tune the model. And basically, if you are interested, I shared the book in the group. Try to read the book, the chapter 2, which walks through all this stuff. I added a lot of stuff, but you can get the basic idea. The book is really good to get you up to speed with, transformers. Yeah.
Doctor, if I may come in here with regards to the question that he asked. So it basically depends on the type of evaluation that you want to do. So what do you want to test? Do you want to test your architecture versus like the architecture in BAT, or maybe your architecture that you do training from the scratch or fine-tuning from BAT? Because in deep learning, all of these small things can affect performance, especially the tokenization you use, the data set you use, the test set that you use. So if you are comparing only the architectures, the two architectures, your deep learning architecture and the BAT, let's say fine-tuning, you try to make sure that the tokenization that you use on all of the data sets are the same. Meaning, leaving other things constant, evaluating maybe two techniques of or two architectures per se.
Yeah.
So if you use different tokenizer to train two different things, it might give you two different results. Which, if you are trying to draw a conclusion, you might not draw an accurate conclusion. So try to know particularly what are you trying to evaluate, what are you trying to compare. I don't know whether they are.
Yeah. So what is your task? What you want to do?
Yes, it's what he is talking about. It's just
your task you want to do. Which one is that? Is it the machine translation, sentiment classification?
No, it's sentiment classification.
Okay. So, okay, let me answer it another way. So you see all these language models. So for example, if you want to do sentiment classification with different methods. So for example, let me start from the beginning using, bag of word. You can train your model using bag of word and get the performance of your machine learning algorithm, maybe using support vector machine or whatsoever. In that case, you are not using, any complicated tokenizer. So you get your performance, maybe you get weighted F1, maybe 8.1. So that's the performance of your model. Now you go to, maybe architecture, you're using deep learning, whether it is, maybe RNN or LSTM, you train your model, right? You do token everything and you have your performance maybe is 8.8. That's it. Now you say, okay, now I do two approaches. Classical approach, which use bag of word, classical machine learning, you use support vector machine, logistic regression, you get your performance. The second approach, you use your machine, deep learning approach using LSTM or RNN, you get your performance. Now you want to move to deep learning method. In deep learning, you want to use pre-trained language model. All these pre-trained language models comes with their tokenizers. Meaning, when you want to use BAT, you will not be able to use any tokenizer rather than that tokenizer for the BAT that was trained on.
Okay.
And it really affects whether that models, the tokenizer that content understand Hausa, if it is in Hausa, if it is multilingual model, the tokenizer maybe may not. But in any case, the tokenizer, because all these languages, they are written in some ways, they can be able to tokenize in some decent format. So you will get a good in some way another performance. But if you want to, train something from scratch, you need to create your own tokenizer for Hausa. So maybe next week, in this section, tokenizer, the first thing we will do, I will show us how to train your tokenizer using Hugging Face, which is really simple. So you can, get a corpus, a large corpus, and you train it to tokenize language like Hausa. So you can use that tokenizer to do some other stuff.
Yeah, I really appreciate it. And Idris too, you have answered a lot of the part of the question.
Okay.
Thank
you. Anyone with question again? Anyone with question? contribution?
Yeah, so like doctor has said, training tokenizer. So doctor, I think it will be nice. I think the Harians we've not done is even knowing to what extent this class is being understood, especially through either assignment or through experimentation or through asking questions and the rest. But even knowing the step-by-step process. So now doctor has explained data pre-processing. Doctor has explained libraries such as class, tokenizer class, doing evaluation and the rest. So to do all of these things, you need to start, let's say, from the beginning, then do this, then do this, then do this. So, but putting it into practice, I don't know whether we have been doing that. We will do class and yeah, people will show that they've understood. But then maybe after a week, when you are taught something again, you may have forgotten what has been taught before. So I don't know whether we've been practicing what has been taught.
Yeah. So what I would advise is for this also slide, just stop. I will share it in GitHub so that if anyone wants to practice. But as Idris says, the best way to get this stuff is just to practice. For example, if we come next week to build on top of what we did today about the data set, the next step is to see how we see a lot about tokenizers and now train a model. If you are liking, you forget something about a data set you have not practiced, the flow will not make sense. You start forgetting, do I understand? And you feel discouraged. But when you practice, then it starts clicking from different ends. So suggestion for this is good. Okay. So that's what we got today. Anyone with question?
Yeah. Yeah. Assalamu alaikum.
Yes, sir.
Yeah. Thank you very much for this wonderful presentation, and I have learned a lot from yesterday and today. As a novice, please, I just want to ask about this BAT language model. It's like what I understand is this BAT, like what you said, is like it was trained to predict the next what, right?
Exactly.
Next what?
Exactly.
Yeah. So the BAT, the GPT-2, GPT-3, T5, all these languages model that you made mention or that you teach us last week, yesterday and today, I understand this is how they work. So, and it's like, is there any project? I mean, is there any way that this BAT model has been applied for the Hausa, maybe to predict the next word for Hausa language?
Yes. So that's a good question. So, these language models, because you said today I show something like whether the BAT language model is multilingual or on case. So the multilingual one was trained on data set from Wikipedia, all the data set in Wikipedia. If a language exists in Wikipedia, then that language model BAT was trained on those Wikipedia. So let me share something so that we can understand. Bismillahirrahmanirrahim. Okay. Okay, let me share my screen so that we can. Oh, I'm sharing still, right? Hello?
Yes.
I'm sharing still, right?
Yes.
Yeah.
Yes. Yes.
Okay. So when we go to BAT, yeah, so models. Okay. BAT, maybe like this. So when we come to BAT here, we can see the data set the language model was trained on, Wikipedia book corpus, right? And you can also be able to see, whether this language model, which language was trained on. So this was on English. It's only on, Wikipedia book corpus, Wikipedia book corpus. That is the on case. I'm not talking about multilingual. So all this information about the language model, you see them here about that. But let's look at multilingual BAT. Okay. So BAT multilingual on case. Okay, here we have 6 languages, it shows. Okay, so we can see these are some of the languages, this but multilingual on case.
Embed.
Yeah, embed. Oh, I think embed. Embed is the multilingual. Okay, anyway, let me just go to embed GitHub. So you can see this is, embed, which is, oh, let me go to the embed, multilingual models that there has. So here you can see BAT-based multilingual recommendation, and you can see how many languages they have. 104 languages, 12 layers, 76 hidden layers, 110 million parameters. And you can see BAT multilingual on case original, not recommended. So here they add formal languages. So this is a new one. They have another BAT case or Chinese. So you can see, this is the languages they have. So meaning that definitely Hausa is in this model. So let me see, HI. Oh, Hausa is not in BAT multilingual. Is that correct? Is it, which one is Hausa is?
Dr. Hausa is not on that one because I checked last week.
Yeah, this one now so baya ciki Afribata Hausa na ciki akwai Embed mai AR.
Akwai XM.
SLMR.
Yes, XML akwai Hausa, amma wannan na duba ne na Hausa.
Okay.
Yau wannan akwai Hausa.
Okay, so for example, Afribata, we can see it has 12 languages. You can see Amharic, Kinyarwanda, Kirundi, Hausa. So it all depends on, language. So now what we are working on, create a language model built only on Hausa with a lot of data sets. If anyone is interested also we are happy for anyone to join us. We will start doing the project to create a language model for Hausa as well. Yeah, so to answer your question, the models, not all of them contain Hausa, but few of them contain. Let me see our Niger Santi data set, Niger Santi paper. So if you come here, you can see, Afribata contain Hausa. SLMR base contain Hausa. MDBata contain Hausa. You can see Rembata contain Hausa. MBAT contain only Yoruba, no Hausa. Yes, so SLMR base, Dibata, and this they contain Hausa. Yeah, you can see.
So now, if I may ask, if I may add, common question issue was more of common next word prediction or sentence completion. Irin kaman using this model to do common application of to do this next word completion. Common, that's what is at stake.
Yes.
Okay, so let me see something. LSRM base.
Come on the phone, if you are typing, it's
okay.
learning. Trying to predict the next word.
Okay, so look at this,
ai lecture wannan ma duk wanda yake amfani da Gboard na Google predicting din next word haka Gboard da muke amfani wannan ko da Hausa ce ko Arabic ko dai languages da yawa dai.
Just excuse me, I want to show something. Okay, so you can see this is what is happening. So bad it just has friends. So let's look at this one. We want to predict the mass word. If I look at it, Paris is the dash of France. Can you see capital 0.997? Can you see heart of Paris 0.01? So you can see from the probability 0.99 is the word with the highest probability that Paris is the capital of France. So any model that was trained, so let me copy this guy and now go to Afribata. And now, Max. Kano Itachi. So this guy is loading. Oh, I don't know what this guy. I don't know why this is not working on Hausa, or because Hausa is there. Anyway, you just get the idea what the meaning of predicting the mask as I just showed. You can try it. I don't know why it's not working here for Hausa that I put. Let me put this another example.
Mask din kaman greater or less bracket yake a wancan ba square bracket. In ka duba anan is in square bracket anan.
Oh, okay. Let me go back then. Look at what he's. But let me because here you can see the model does not understand Hausa. Oh, you can see the Hausa language. Let me, because maybe it was not trained on Hausa data set. Hausa language to study group. Hausa. Which country? You can see bai gane shi ba. Okay, let me.
Ya gane mana doctor. Kaga ai question ne kake so kai, so you have to have question mark a gaba. So I put the question mark.
Yeah, gane shi. So let me try the free head actually better. Oh, here, okay, Kano. Okay, you use this. Okay, let me see. Kano. Yes, something like this. It's still. Okay, anyway, I don't know why this API is not working. Expected. Anyway, so but just you just get the idea. You can try, Okay, let me. Okay, you can just try it from your own end. I don't know why it's not, but you get the idea. Yeah. Any question? And if you want to use this model Robata, which was trained, this is what you just gonna do. Anyway, we will discuss about this later in the next class, how we can train model, how we can download the model, but now, as I said, what our interest is now to go, step by step to see what this, is doing. Now, as we say that things for you to do Hugging Face, the first thing is data set. Now we understand thoroughly how we can deal with the data set. We now understand Tokanada. Then next week, what we are going to do is we're going to start from where we stop on Tokanada and now see how we can load models and do stuff. Any question before we go again? Any question again?
One API is in Hugging Face. Are they free?
Now?
APIs in Hugging Face. Are they free? Okay.
Yeah, sai ka biya kuɗi wani ai ba free za ka baka ba honorable.
Irin kuɗin a nufi na da tsada ne sosai.
Hello, kuna ji na?
Yeah.
Hello?
Muna
Okay. That is where they make money.
Okay.
The inference. Okay. So wani ne computer na ne take ƙara ne? Kuna jin ƙara daga computer na?
Takan yi ta dauke kuma.
Hello?
Ɗazu dai mun ji karan amma yanzu babu.
Okay. So we see inshallah tomorrow next week and continue our discussion. Bye bye. If you have any question you can ask in our WhatsApp group. See you next week. Bye bye.